Oh, okay, we started our discussion of functions, seems like a long time ago. Function is a rule that assigns to each x value exactly one, only one, not two or three y values. The last time we looked at piecewise functions where they're broken into different parts. And today we're just going to sort of pick up a little mishmash of different things involving functions. The first thing we're going to see is something called operations. And that'll be problem 1. Then we'll have problems 2 and 3 dealing with something called difference quotient. And then 3 through 11, something called composition of functions. And then there's 2 review problems. I think they're both cut point problems, 12 and 13. I don't remember why you didn't wind up with 15 problems, but I guess maybe when I was making the assignment I decided, that's enough. More than likely I took a break and forgot to go back and add the 2 other parts, 2 other problems to get it up to 15. In case you haven't noticed. In case you haven't noticed, we try to put about 15 problems on the average in each assignment. Sometimes there's more, sometimes less. But the first thing, operations. When we talk about operations on real numbers, y'all know what that is. Addition, subtraction, multiplication, and what's the last one? Division. That's what we're going to look at today for the first problem. Adding, subtracting, multiplying, and dividing functions. Let's look at problem 1. Okay, so we have problem 1. F of x is 5x plus 4. And g of x is 4x minus 5. That 5x plus 4 looks sort of... That's blue isn't showing up well. No, that was blue and this was a purple. I'm switching to blue. And the instructions here say to find, look at this notation, f plus g of x, f minus g of x. That fg, I don't see an operation there. If you don't see an operation, what do you assume is the operation? Multiplication. So that's saying f times g and then f divided by g. All of these will be in terms of the variable x. Addition, subtraction, multiplication, and division of functions is nothing more than algebraic addition, subtraction, multiplication, and division. Switch the screen. So, f plus g of x. That means just add f of x and g of x. Instead of writing out the x twice, this means the same thing as writing f of x, which is the blue function, plus g of x, the red. So we'll just write it out. I'm even going to put parentheses around each function just to make sure it's clear. F plus g. These parentheses here are just to separate that this is function f and that's function g, especially if you're living in just a black and white world. Here function f is in blue, function g is in red. 5x plus 4x, that's going to be 9x. So just combine the like terms. And then a 4 plus a negative 5, what's that going to be? 4 plus a negative 5? Negative 1? Yeah. Realize that adding and subtracting functions is just algebraic addition and subtraction, which means combining like terms. The only thing new here is, what does this notation f plus g mean? And it's not surprising. It means take what you have for f of x, add it to what you have for g of x. And now it's f minus g. We'll get all these answers and then we'll type them in. F minus g of x. That just means write down your function f and subtract this minus right here. It's sort of hard to tell the difference with the colors. Is that one right there? F minus g. In the previous problem, oops, wrong color. G. These parentheses didn't really change anything. I could have written it without them. But here, there's something you've got to do. When you have a minus in front of parentheses, what do you have to do there? Distribute? Yeah. So I'm going to write it now without any parentheses. So 5x plus 4. That first set of parentheses has nothing in front of it to distribute. Those are unnecessary parentheses. But the second set of parentheses, they're necessary because you got to distribute that minus, hence changing the signs on the 4x minus 5. So we have a minus 4x, and then a minus minus 5 is going to be plus 5. Now combine the like terms. Let's see, what are we going to get? 5x minus 4x is just 1x. 4 plus 5, x plus 9. Is that what y'all get? So to subtract functions, just distribute the minus and combine like terms. You know, let's type those in right now so we don't get timed out. 9x minus 1 and x plus 9. Okay, now we need f times g and f minus g. No. I mean f divided by g. This notation means multiply f and g. If I write down function f, and I'm giving away what we're going to have to do by using these parentheses, 5x plus 4 times 4x minus 5. Function multiplication is just plain old algebraic multiplication. You know how to multiply those. What are we going to have to do? FOIL them out. I agree. 5x times 4x is 20. X squared. First. Outer. 5x times a minus 5 is a minus 25x. What's the inner going to be? 4 times 4x. 16x, good. And what about the last term? 4 times a negative 5. I'll get you started. It's a negative 20, so minus 20. Now just combine the like terms. Nothing to combine with the 20x squared. So I'll just write 20x squared. Negative 25x plus 16x. Is that a negative 9x? And then minus 20. So you just multiply functions the way you would algebraically. Here it's multiplying binomials, so just FOIL it out. Now, last one they want is f divided by g. Notice they're denoting the division as a fraction. And notice they're trying not to write the x twice. Okay? Like it's f of x minus g of x. f of x times g of x. Here, it's f of x, that's the 5x plus 4, over g of x. Sometimes students decide when they're doing this, they got to distribute an x through something. No. Okay.
No, for dividing algebraic expressions, you ask yourself, can you factor and cancel any common factors? In this case, can you? Can either of those things be factored? If they can't be factored, you can't cancel. There's the final answer.
Go ahead.
Division turns out to be the easiest one of the four. So that was 20x squared minus 9x minus 20 and f divided by g. Typing in that fraction, I'd use the fraction hot button. We have 5x plus 4 on top and 4x minus 5 on bottom. But we're not through with this problem because there are other instructions as well. Notice they want you to give the domain of each.
And as I was going to review this beforehand, but Tim seemed to be eager for me to get started. Go ahead and show this page. Remember when we discussed functions for the first time, we said to find the domain of a function when it's written as an equation. If there's no square roots and no fraction, the domain is negative infinity to infinity. We emphasized that again the last time when it was asking for the domain of quadratic functions. With a quadratic function, ax squared plus bx plus c, there's no square roots. There's a square, but not a square root, and there's no fraction, so the domain is all real numbers.
With that in mind, what's the domain of f and g?
Yeah, what's the domain of this?
They don't ask that, but
I'll get you started.
All real numbers.
I think they want to say negative infinity
to positive infinity.
They don't ask us about that one, but there's no fractions, no square roots, so the domain of f, all real numbers. What about g? All real numbers. Now, for f, for these others, look through the whole work. Don't look just at the final answer. But if you look through here, there's no fractions and no square root. So the domain for f plus g, all real numbers. What about f minus g?
Once again, you're not just looking at the final answer, because you could have had a square root in one problem and wound up
subtract minus another square root.
Minus a square root, so it disappeared, and you wound up with something without a square root. So
but that's not.
So you look through and make sure there's no square roots or fractions anywhere in the work, and there aren't. So all real numbers. Y'all look at f times g. Y'all tell me what the domain's going to be there.
Are there any fractions or square roots? So the domain is
all real numbers.
You want to go ahead and type those in?
Okay.
This one here, is there a fraction? There's not a square root, but
wait a minute, you told me that.
I know. The part D, there's a fraction, so it's going to be more involved.
Okay, but we'll type in left parenthesis negative infinity, comma, infinity, right parenthesis, and I'm going to do something I don't do that often. I'm going to copy that, so because then we can just paste in, here's f minus g, and I just copied it, I'm pasting it in. We don't have a negative infinity to positive infinity hot button, but since we have to type it twice, I'm feeling lazy today. I'll just copy and paste it. But the domain of f divided by g, I'll tell you right now, it's not going to be all real numbers.
Let's see. Right here. This was on the day, that first assignment over functions. To find the domain, we say the denominator of the fraction can't be 0. So like on this one, x can't be negative 13. In words, you'd say all real numbers except negative 13, but they don't want you to write it out in words, do they? They want this interval notation. So we're going to have to do the same thing here on this one. The denominator can't be 0. So we say 4x minus 5 can't be 0. So move the 5 over and divide by 4. So there's only one number x can't be. The fraction 5 over 4.
Could you plug in 50 million for x? You may not want to, but could you do it? Yeah,
Yes,
you can plug in.
The only number you can't plug in is what?
5 over 4. This is saying x can be any real number except for 5/4. But how do we say that using interval notation?
There it is in words. Back when we were in school, before the math world went crazy with interval notation, that's how we were told to do it. Write it out in words so that people that don't know any math can at least read the words. Well, those days are long gone. So how do we get the interval notation for all numbers except 5 over 4? Well,
You don't want to shade 5 over 4. That's like a denominator cut point.
So open circle means not including, and then you want everything else. So the graph I've drawn here is just to help me get that interval notation. I want everything except 5 over 4. So it would be negative infinity, comma, 5 over 4, parentheses, because there's an open circle. You wouldn't want to put a square bracket, because then you'd say including 5 over 4. No, 5 over 4 is the one number you gotta exclude. Union 5 over 4, comma, infinity. And this is the fancy way of writing all numbers except 5 over 4. Okay?
Okay, so typing that in. Let's see there. Left parenthesis, negative infinity, comma, 5 over 4. Get out of the denominator before you close your parenthesis. Union, left parenthesis, 5 over 4. Get out of the denominator before you type your comma. Infinity. I wonder if you put that comma in the denominator if they take it.
You want to see?
I do.
Okay.
They shouldn't. I'll tell you that much right now. If they do, I'm going to be a little disappointed in them. Oops. They should not take that.
You see what he just did?
I put that comma in the denominator.
Did it take it?
Let's see.
No. They don't know what's wrong, but the comma's not supposed to be in the denominator. Another thing you can do sometimes that'll mess them up and get a right answer wrong, hitting space keys. Never, ever, ever hit a space key.
No space keys, no capital letters.
Oh, wow. Only 19 minutes to do this first problem. They won't all be that long, hopefully.
So, for the basic operations, the real number operations that we can extend to functions, addition, subtraction, multiplication, and division, it's just algebraic addition, subtraction, multiplication, and division. Next, we have something called, it's a fraction called the difference quotient.
And I thought I would remind them of something. When working with function notation, again, this is stuff from the day the class meeting, what was that date? October 15th.
A week ago today, wasn't it?
Well, it was, okay. With function notation, whatever's in the parentheses, you plug it in for x. So if you're trying to find like h of negative 20, then it's 6 times negative 20. If it's a number, you just plug it in. If it's just a single variable, you just replace it. But it says number 11 that I wanted to look at. No matter how messy or strange it is, whatever's in the parentheses, you plug it in for x. With that in mind, number 2, let's see what it looks like. Problem 2.
Are you going to write?
F of x
Equals
x squared minus 6. This is a 3-part problem, ABC, and if you look at the part C, that's something called the difference quotient.
It's a quotient. Notice it's a fraction. There's division, so there's a quotient. And what's that operation up on top connecting the functions? A minus, hence the name difference quotient. Not very original, I suppose.
But you're multiplying and dividing. Subtracting and dividing. We'll go through this piece by piece and see a 3-step process for finding that messy looking fraction there, that difference quotient. Part A.
Oh, but look at something. Here on part number 3, they just tell you find the difference quotient. They're not going to talk you through the way number 2 is. So even though they don't say break it into parts, we break it into parts. We use these 3 steps that they use here on number 2. First of all, we find f of x plus h. Then we subtract off the original function. And finally, we find the difference quotient. We use those 3 steps even when they don't ask for the 3 steps. If you're looking for a difference quotient, you need to break it into those 3 steps for the best success rate. I'll be quiet.
So to find f of x plus h, whatever's in the parentheses, you plug that in for x. Now be careful. When I replace this x with x plus h, I'm going to put that in parentheses because you're squaring that whole thing. I'm replacing the x with what's in the parentheses. Now to square this, you don't just square the x and square the h. How do I square 2 terms?
A sum or difference. I remember doing that the very beginning of the semester.
On the second assignment. I'll give you a hint. Square means times itself.
So what are we going to have to do?
To get this x plus h squared.
We're going to have to FOIL it out. Write it twice and FOIL it out.
And this is going to be my scratch paper. Right here, I'm FOILing out x plus h times x plus h. I would have x squared for the first term plus xh for the outer, or hx. How do you like it, Tim? Xh
Alphabetical
or
order.
Okay.
If your term has 2 different letters, always write those letters in alphabetical order. X
So
times
you can
h,
spot
you
the
write
like
as hx. So you spot the like terms. What's the inner product going to be? You tell me. Another hx. You see, if you'd written the first one as an xh and the next one as an hx, you might not have noticed they could be combined. That's why I say if you have 2 different letters in the same term, write them in alphabetical order. What's the last term? H squared. Okay.
So I'm squaring x plus h times x plus h. Now I'll combine the like terms. There's nothing to combine with the x squared, but that 1hx plus 1hx is 2hx plus h squared. So I'm going to come over here and replace this x plus h squared with what I have written right here. X squared plus 2hx plus h squared. And sometimes students forget to write. What do I need to write right here? Minus 6. And that's f of x plus h.
We went to our function f. We replaced the variable with x plus h and simplified. I'm going to go ahead and type that in. So x squared plus 2hx plus h squared, and we still have that minus 6. Now part B, f of x plus h minus f of x. Realize you'll use part A, the answer you got in part A, to answer part B. And you'll use the answer in part B to answer part C. So you're looking back at what you just found. If you understand what they're asking for here in part B, it's real easy. If you understand what they're asking for, you can write it down without any work.
F of x plus h. Have we already found f of x plus h? Well, yeah, that's part A. So we're going to take our answer from part A, and let's think of subtraction the way you thought of it in elementary school. Take away. So look at your answer from part A. Take away f of x. So take away everything from the original function. You can do this really without any writing, other than just write out the answer. Like right here, look at your answer from part A, and I'm going to take away the x squared. So imagine taking away the x squared. What else am I going to take away? What else is in the original function?
X squared is dropping off.
What else am I going to take away? The minus 6. What's remaining? 2hx plus h squared.
If you're doing this correctly, every term that's left will have the letter h. The things that don't have h's have to be in the original function, so they'll subtract off.
Okay.
You'll be left only with the terms containing h.
I'm going to try to show my thought process of what I just did. Take your answer from part A, take away the x squared, so I'll just mark it out. Take away the minus 6, I'll mark it out. And what I'm just trying to do here is write out what I did just a moment ago, just by covering up. 2hx plus h squared.
I think that's clear.
You want to,
2hx plus
as our dear mother would say, clear as mud.
2hx plus h squared. Was that it? Yeah.
Now part C.
Okay, hold on. Now, you're going to take the answer from part B. You're going to use the answer in part B to answer part C.
Looking at what, Tim, what just happened?
Nothing.
Oh, yeah, something just happened. My hand is,
Oh.
wow. Oh, gosh.
Well, if you put your hand right at the exact spot, maybe it'll start back. No. Oh, look at that.
Huh.
Y'all see what's happened? It's still recording. Show both hands, Tony, so everyone can know. Show them up. Yeah. But it's still showing the hand here. I think we're frozen, aren't we?
Oh,
wow. I wonder if I pause it. Nope. Okay, there's going to be 2 videos from today. I'm going to stop it and then we'll start it back.